Hello, I'm Dustin Morrill. I'm a research scientist at Sony UAI, and this is my paper on composing efficient, robust tests for policy selection at UAI 2023. Consider an AI deployment situation like the Race Together event in the Gran Turismo 7 PlayStation game. With hundreds of candidate deployment policies, you can only afford to run them on a fraction of possible test scenarios. We frame this problem as robust test construction. Each test is a set of test cases and a weighting over them to yield a final score when the test is applied to a policy. The goal is to construct an efficient test, one that uses a small number of test cases to produce scores like a test that uses all the test cases. Our procedure begins by performing rollouts to evaluate policies we have on hand on each test case and saving the average results to a matrix. We then perform robust population optimization for a small set of test cases, RPOSST for short, on this matrix. RPOSST selects M test cases and a weighting over them to minimize a loss function, like absolute error between its test scores and target scores. Parameters of the target scores are determined by an adversary, which is what makes RPOSST robust. After running RPOSST, we can apply its test to all future deployment candidates. RPOSST frames this optimization problem as a two-player zero-sum game. The protagonist chooses a test, then n samples are drawn from our uncertainty distribution psi, and finally the antagonist chooses k of these outcomes. Each outcome from psi is a tuning policy to evaluate and a target test case weighting. Both players receive payouts based on the average loss of the protagonist's test applied to the antagonist's outcomes. The antagonist chooses outcomes that maximize the protagonist's loss, which forces the protagonist to learn to be robust to the uncertainty represented by psi. RPOSST has an optimality bound that holds with high probability, as well as a deterministic bound if psi has finite support. We apply RPOSST to a toy racing game, as well as poker and Gran Turismo 7, where we find that it tends to produce lower error tests on holdout policies compared to ablations and an algorithm inspired by the education test construction literature. Looking more closely at the Gran Turismo results, we can clearly identify the three best policies by using a RPOSST test of just size 2. Come see our poster at UAI 2023. Thanks!